Hello friends, in this video we are going to discuss development of embryo. Now as we know that in angiosperms, double fertilization process occurs where one male gamete fuses with secondary nucleus to form endosperm. Endosperm development we have already studied in previous video, that is of three types: free nuclear type, cellular type and halobial type. Endosperm always form prior to the development of embryo because endosperm is a nutritive tissue, and so in order to provide fast developing embryo the complete nutrition, endosperms is formed before the embryo develops. Now in this video we will see what is the future of zygote. Now as the second male gamete fuses with the female gamete, the resultant is zygote and the process is called syngamy. Zygote is a diploid cell and this zygote first undergoes the mitotic division in the transverse plane. Zygote will undergo the first mitotic division with a transverse plane and it will result in the formation of two types of cells. One is called as basal cell at micropylar end and another is called embryonal cell at the chalazial end of embryo sac. Basal cell is a large cell and micropylar end is a small embryonal cell at chalazial end is a small cell. As you can see in the diagram, let's focus on the diagram. This is our zygote, which is a diploid cell. First this zygote undergoes the mitotic division. So यहाँ पर होगी first mitotic division and this is going to be followed in a transverse plane, due to which we get two cells. One is called as the basal cell, suspensor cell, another is called as embryonal cell. In the NCERT book, this diagram is given just reverse. Suspensor is being shown at this end and embryonal is shown at that particular end, right? So there is no confusion. If there is any confusion, then I can make a diagram of embryo sac. Just imagine this is your embryo sac. Suppose this is your embryo sac. Then you know this is a micropylar end. This is a micropylar end from where the pollen tube has been entered. Right? This is the micropylar end from where the pollen tube has entered. And this is a chalazial end where three antipodals were present. And in a center there was a endosperm development. So now the endosperm is completely filled, the embryo sac. The embryo sac is completely filled by the endosperm because the development of endosperm is prior to the development of embryo. So embryo needs to get embedded in the endosperm in order to derive complete nourishment. तो जो माइक्रोपाइलर एंड की तरफ होगा बेसल सेल, दैट इज योर सस्पेंसर सेल, और जो चैलिजल एंड की तरफ होगा दैट इज गोइंग टू बी योर एम्ब्रियोनल सेल. आई थिंक दिस इज क्लियर टू यू दैट इफ यू ड्रॉ an embryo sac, how this embryonal cell will be towards inside, towards chalazial end, and suspensor cell, which is a large cell, is towards micropylar end. So after the first mitotic division in the zygote, which is on the transverse plane, I obtain two cell stage. One cell which is towards micropylar end is called suspensor cell, which is a large cell, and another cell which is towards chalazial end of the embryo sac is the embryo cell, which is going to be a future embryo, and this cell is a small size cell. Now फर्दर दोनों सेल्स के अंदर डिविजन्स कंटिन्यू रहेंगे. इन सस्पेंसर एज वेल एज इन एम्ब्रियोनल सेल सम डिविजन्स आर गोइंग टू कंटिन्यू. सो सस्पेंसर सेल will undergo the transverse division, and due to the transverse division I will get 3 to 4 cell stage of suspensor. You can see if this is your suspensor cell, इसमें डिवीजन होगा ट्रांसवर्स, I will get 2 cells. Again दोनों cells में होगा ट्रांसवर्स, I will get 4 cells. So like this the suspensor is going to be formed in a chain like structure. The cells of the suspensor, they are going to get arranged one over another. But when you talk about the embryo cell, in this embryonal cell at the chelazal end, the first division is going to be the longitudinal division. So the division of the plane is the longitudinal division, and after that the division is a transverse division, so that we will get a globular shape type of embryo. Because if there is a transverse division here also, then embryo ka formation will also be in the form of chain like structure, like a filament. But embryo does not form a shape of filament, it is a shape of globular mass. So what is the reason? Because the first plane of division is longitudinal and then followed by the transverse division. So in this way we started with the development of embryo. So what is going to happen? In each of the upper basal cell and the lower embryonal cell, the division remains to be continued. Suspensor cell will undergo continuous transverse division 2 or 3 times, and it will form at least 6 to 7 celled stage of suspensor. So 6 to 7 linear arrangement, one over another, one over another. There is a complete 6 to 7 cell stage in suspensor. And embryo, where the first division is longitudinal division and followed by transverse division of plane, and we will get 4 cells, they are arranged in such a manner. Now question arises, what is the function of suspensor in this structure development? As you know that here is complete endosperm being present. The complete embryo sac is filled with a nutritive tissue called as endosperm. And we want our embryo to get complete nourishment from the endosperm. So in order to embed this embryo more and more into endosperm, the suspensor is going to develop. As soon as the suspensor will be 6 to 7 celled stage, it will push this embryo to get embedded more and more into the endosperm to derive nourishment. Not only this, if you see the suspensor beta, then suspensor may the lowest cell, which is towards the micropylar end, the outermost cell which is towards the micropylar end, is very large in size. The function of this cell is also very important. We will see in next diagram. Now, see the next diagram. Again I repeat, zygote undergoes the first division, which was in the transverse plane, basal cell at micropylar end, which is called suspensor cell, embryo cell at the chelazal end. Now in the suspensor cell there is transverse division. Transverse division continues. One is a large basal cell which is always towards the micropylar end. So one cell which is at the basal site, which is towards the micropylar site, this is the large cells, whereas remaining others, these are the small cells. So other cells form a long suspensor which push embryo into endosperm. So I think function of suspensor is clear. Suspensor main function is to derive nourishment from the nucellus region or from the nutritive tissue or the nourishment which is surrounding the embryo sac, as well as to embed, to push the embryo deep into the endosperm so that embryo can get complete nourishment. Now, there is a chain of 6 to 7 cells arranged in a linear fashion, one over another, where you can see one cell is very large in size. This cell is called as hostorial cells. And hostoria, you know, hostoria is the cell which extracts the nourishment. Hostorias are the cells which always meant to extract the nourishment. So this cell is going to extract the nourishment from surrounding the embryo sac. Surrounding the embryo sac is also there is nourishment. So from micropylar end it is going to derive the nourishment, that is the hostorial cell. Whereas if you see in the lowermost cell, the embryonal cell which is towards the chelazal end, the first division was longitudinal division and then followed by other plane of division, due to which a globular embryo is formed which gets transformed into embryo later with the development of radicle, plumule and cotyledons. Okay, let us see. This is a 4-celled stage of embryo. And continue with the division. Next stage we have obtained is 8-celled stage, pro-embryo stage. Now, ये चारों cells के अंदर further division होंगे, and due to which we get one more set of 4 cells. So 4 cells अंदर हैं और 4 cells बाहर है. ये चारों cells में division continued रहा, and we get another set of 4 cells which are making the external linings, while these 4 cells are the internal linings. These external cells in future are going to make the outermost layer of the plant body, that is called epidermis. So this layer is going to be called as the dermatogen. So pro embryo में या early embryonal stage में ये जो एक्सटर्नल साइड पर सेल्स बने हैं, ये जो चेन बनी है, या ये जो 4 सेट ऑफ सेल्स बने हैं, दिस इज गोइंग टू बी मेकिंग द आउटर मोस्ट कवरिंग ऑफ द प्लांट बॉडी, एंड दिस इज कॉल्ड डर्मेटोजन लेयर. With further development, if you see, the embryo becomes more and more massy in structure. This is a globular shape embryo. So after 8-cell stage pro-embryo, the next stage is called as globular embryo, because the development is continued, because the divisions are continued, and now we are getting 16, 32, 64 celled stage of embryo, and this is a mass of the cells, and this shape attained by the embryo right now, this shape attained is called as globular shape. Now if you look to this shape, the outermost set of the cells is called as dermatogen, और बीच में आ गए यहाँ पर इसके जस्ट जो नेक्स्ट बिलो लेयर है, दिस इज कॉल्ड एज द पैकिंग सेल्स, विच इज मेकिंग द intermediate parts of the plant body, which is going to pack the complete plant body, is called as the ground meristem. You must have heard cortex, right? तो cortical cells जितने भी होते हैं, right, that is a ground meristem. Whereas if you see the innermost cells, this innermost cells, then these cells are called as procambium. Again I repeat, when this 8-celled stage changes into further division with making a globular mass shape, then the 3 layers are going to be formed. The 3 layers are, the outermost layer is still called as dermatogen, which will make the epidermal linings. The intermediate layers are going to make the packing tissues called as ground meristem, whereas the innermost layer of the cells are called as procambium. Procambium means the most dividing cells, or which are the cells which continues to remain dividing in the plant body, and these are going to become in future the meristematic tissues. So procambium will later on becomes the meristematic tissues, so that shoot meristem, root meristem, plant body remains, continue to increase in length and in growth, right? Now if you look to this structure, ये जो सस्पेंसर बॉडी है, इस सस्पेंसर बॉडी का जो लास्ट मोस्ट सेल है, दिस इज द सस्पेंसर बॉडी, ये लास्ट मोस्ट सेल है टुवर्ड्स माइक्रोपाइलर एंड, and this is the last most cell towards the embryo. So suspensor, the last cell towards the embryo, is called as hypophysis. The cell situated at the terminal end of the suspensor, which is in contact with the globular embryo, is called as hypophysis, which later give rise to root meristem. Means यहाँ से start होगा root का formation. ये cells for the root cap बनाएगा. And if you can see this structure, then this structure is called as the root tip. So root tip is going to get covered and protected by a covering called as root cap. Now if this is a root part, means this is a radical part, तो इसके just opposite क्या होगा? That is going to be plumule part, which is going to form the shoot. If this is a root part, then from here the shoot part is going to get emerge out. So this is radical, then this is going to be plumule. It means this is going to be embryonal axis. तो ये आगे चलकर क्या बन जाएगी? embryonal axis. So later diagram में हम इसको देख लेंगे. Again I repeat with this much portion only. So this is a large basal cell towards the micropylar end, which becomes little large in size, called as hostorial cell. Hostoria of the suspensor is going to derive nourishment from the structure surrounding the embryo sac within the ovary, as well as 6 to 7 celled linear arrangement of suspensor is going to be formed, which are not very of big size. The function of this suspensor is to push embryo more and more into endosperm so that embryo can derive nourishment from the endosperm. Again, अगर आपको स्ट्रक्चर क्लियर नहीं है तो ऐसे इमेजिन कीजिए, ये आपका एम्ब्रियो सैक है, दिस इज योर एम्ब्रियो सैक, and this embryo sac is completely filled with the endosperm, completely filled with the endosperm. This is your micropylar end and this is going to be your chalazal end. This is going to be your chalazal end. So micropylar end की तरफ जो suspensor का cell होगा, basal cell, this is going to become large called haustorial cell so that it can derive nourishment from the surrounding of the ovary. I mean, this is the tissue inside the ovary or ovule, that is nucellus, as well as these linear cells, they are going to embed embryo in the endosperm. Endosperm is the main triploid nutritive tissue which is forming prior to the embryonal development. Whereas if you see to the embryonal cell, इसमें पहली longitudinal division हुई, फिर transverse हुई, I get 4 celled stage, continued with the division, I get 8 celled stage, where the outermost lining of the cells become the dermatogen and then continued with the division to form globular shaped embryo. Globular shaped embryo is divided into 3 layers. The innermost layer is called as procambium, the middlemost layer is called as ground meristem, and the outermost layer is called as dermatogen. Dermatogen, which is going to make the outermost lining of the plant body. Ground meristem, which will make cortical type of cells, means the packing tissues, and procambium will become the meristematic or will attain the meristematic nature, means these are the continuously dividing cells which help in the development of plant body. The lowermost cell of the suspensor touching to the embryo, the lowermost cell of the suspensor touching the embryo is called hypophysis. This cell is called as hypophysis, which will later on help in the development of root meristem. This cell in future will form the root cap. Hypophyseal cell will form root cap, and this root cap is protecting the root tip. Root portion always arise from the radicle. So this is going to be the complete radicle cells. When the seed will germinate, then this is the cells which will help in the radicle development. And just opposite to the radicle, if I will say this is a shoot, meristem यहाँ से बनेगा. So this is going to be the plumule side. So if this is plumule, this is radicle, then it means this is a complete embryonal axis. Am I clear with this? Now see to the next diagram. If you look to the diagram, after globular shape, the next shape which is going to be attained is the heart shape. Why heart shape? Because the cells will continuously going on dividing and dividing and dividing. The division is not going to be stopped because it has to grow. Embryo will divide, and if it will divide, then it will emerge out into the formation of a cotyledonary structure. You know, cotyledons in which the complete food is going to be stored for future seed formation, right? In order to provide nourishment for the future purpose, seed is going to store the food extracted from the endosperm in the form of cotyledons. So यहाँ से 2 cotyledons बन जाएंगे, and cotyledons, because of continuously storing the food, they will become heavy, और इस तरीके से they are going to hang out in the form of a heart-shaped structure like this. Clear? And this is a complete embryonal axis. Suspensor little start getting reduced from here. Haustoria, these are the cell. This is going to be the hypophyseal cell. और अब यहाँ से आप radical formation देख सकते हैं. This is going to be plumule formation, and this is embryonal axis. Embryonal axis is also called as tigellum. Right? So after heart-shaped embryo, the next stage of the embryo is horseshoe-shaped embryo or torpedo-shaped embryo. The next shape which is going to be attained is torpedo shape or horseshoe shape. आपने घोड़े के ये देखी होगी, नाल देखी होगी, और उसकी shape देखी होगी like this, right? Like this. सो इस तरीके का शेप आपको यहाँ पर एम्ब्रियो का दिखेगा. सस्पेंसर इज ऑलमोस्ट गेटिंग रिड्यूस्ड. दिस पोर्शन इज गोइंग टू बी रिप्रेजेंटिंग द रेडिकल, और रेडिकल के जस्ट ऑपोजिट दिस पोर्शन इज गोइंग टू बी plumule. So this complete portion is going to be radical. This complete portion is going to be plumule. In between, this is a complete embryonal axis. While these are two cotyledons, which later on taking the shape of horseshoe shape cotyledons. And later on, the NCERT books give you this kind of diagram. So this is a complete developed embryo in dicots. This is a dicots because two cotyledon I am showing. This is a dicot. तो रिवर्ट डायग्राम दिखाया है. रिवर्ट डायग्राम में अगर आप देखेंगे तो ये आपका रेडिकल है. रेडिकल विच इज बीइंग प्रोटेक्टेड बाय द रूट कैप. रेडिकल एंड दिस इज hypocotyl. Now what is hypocotyl and what is epicotyle? Now see, if this is an embryonal axis, and this is going to be radical, and this is embryonal axis, and this is going to be plumule, right? So the portion of embryonal axis just above the embryonal axis from which the radical arises, the portion of embryonal axis extended to form radical. तो रेडिकल के जस्ट नीचे वाला और एम्ब्रियोनल एक्सिस का एक्सटेंशन, रेडिकल के जस्ट नीचे वाला एम्ब्रियोनल एक्सिस का एक्सटेंशन is called as sorry this is plumule. I'm very sorry, this is plumule. So embryonal axis का extension just below the plumule is called as epicotyle. Again I repeat, the portion of embryonal axis just below the plumule is called as epicotyle, and the portion of embryonal axis from which the radical is going to form, तो रेडिकल के जस्ट पीछे वाला पोर्शन इज कॉल्ड एज हाइपोकोटाइल. दिस इज हाइपोकोटाइल एंड दिस इज रेडिकल. ये कंप्लीट आपकी एम्ब्रियोनल एक्सिस की स्ट्रक्चर है. सीड के अंदर एम्ब्रियोनल एक्सिस का डेवलपमेंट है. इफ दिस इज अ एम्ब्रियो मीन्स दिस इज एम्ब्रियोनल एक्सिस, देन एम्ब्रियोनल एक्सिस का एक्सटेंशन कॉल्ड एज एपिकोटाइल. सो अ पोर्शन ऑफ एम्ब्रियोनल एक्सिस और अ पोर्शन अबव द एम्ब्रियोनल एक्सिस पार्ट joining the plumule is called epicotyle, and the portion below portion of the embryonal axis joining the radical is called as hypocotyle. Clear? So in this diagram you can see this is a complete beta embryonal axis, this is a embryonal axis, and this is a radical. So embryonal axis ka below wala part, this much part is called hypocotyle, and embryonal axis ka above wala part is called epicotyle because from where the plumule is arising. Clear? So this is plumule, this is radical. Radical is protected by root cap because यहाँ से root बनेगी and each root is going to get protected by root cap. This is embryonal axis with epicotyle plumule. This is embryonal axis with hypocotyle radical. And these are the two cotyledons which are going to reserve food for the future purpose. In this way, the embryo gets developed in the plants. Again, you can take the diagram. You can take the screenshot of the diagram. Right? This is the first division of the zygote, first mitotic division, which will form two cells. One above is suspensor, actually which is a basal cell, and another is embryonal cell towards the chaliceal end. Division continue, suspensor में division continue with the transverse division, form a chain of cells, but in embryo cells the division is longitudinal and then transverse, form 4 celled stage. After which the division continues in suspensor, form 6 to 7 celled stage, where the one which is towards the micropyle is a hostorial cell to derive the nourishment, and the lowermost cells of the suspensor attached to the embryo is called as hypophyses. The division continued in embryonal cells simultaneously, which is going to change from 4 cell to 8 celled, 8 celled to globular shape to heart shape to torpedo shape. Now in this 8 celled stage, if you see to the outermost layer, this is going to form dermatogen, and much more clear when you see the globular shape. In globular shape, you can see 3-layer arrangement. The innermost layer are the meristematic cells layer for future. This structure is called procambium formation. In between is a packing tissue ground meristem, and the external one is dermatogen. This is going to be embryo axis with there is a radicle in future, and this has become plumule for future purpose. You can take the screenshot of this diagram also. So A, B, C, C, D, E. Okay. And later on, when the division is continued and the food is going to stored continuously in the cotyledons become heavy, and due to heaviness, they get hang like in structure, making a heart-shaped embryo. Right? So in dicots, complete food is going to get stored in the form of cotyledon. As we know that the seeds of dicots are non-endospermic, because during the development of seed only complete endosperm get consumed and food gets stored in the form of cotyledons. This is the embryonal axis called tigellum with radicle and with plumule. Then later with the development, the structure which we get obtained is called torpedo shape or horseshoe shape. This is embryonal axis, radicle and plumule. And later on the diagram of NCRT which gives you the structure like this: radicle with root cap below, plumule above. And these are the two cotyledons. The portion of embryonal axis going above to join the plumule is called epicotyle, and the portion of embryonal axis below joining the radicle is called hypocotyle. And this is a complete structure of dicot embryo. Dicot embryo and monocot embryo, few differences are there, and differences lying in only few things. Like in monocot embryo, this suspensor is only 3 to 4 celled stage. It is not 6 to 7 celled stage like in the case of dicot embryo. In monocot embryo, only 3 to 4 celled stage suspensor is formed. This is the one difference. Another difference, only and only globular shaped embryo can be observed in monocots. There is no heart shape, there is no torpedo shaped embryo is observed. So this is all about the development of embryo in the plant, which is a post-fertilization event. After this, we will see the dicot seed and the monocot seed, because once the embryo is completely developed, food is stored in the cotyledons, how the dicot and monocot seeds are going to develop.